Welcome. So in this video, we'll be answering question 6 here. It says, given that the definite integral of f of x from 5 to 2 is equal to 12, evaluate the following. Well, let me highlight this in yellow because this is going to be very important, and we're going to come back to this and again and again and again. We need to remember that this right here is equal to 12. So this right here, this definite integral of f of x from 5 to 2 is equal to 12. Let's remember that because we're going to basically be trying to find this in each of these answers here. You'll see what that means soon. All right, the first one that we've been given, and let's write it out, is the definite integral of f of x from 2 to 5. So 2 to 5 f of x dx. Now, how is that different to what we've seen up here? Well, as you can see, here I have 5, 2. Here I have 2, 5. So I've just swapped these around. And this is where you just need to memorize this property of integrals, that when this happens, you're going to end up with a negative of what you started with. When you swap those terminals, when you swap those upper and lower boundaries, you end up with a negative of that. Now, as I said, do you see how we have what we started with? It's just going to be that, but now it's negative. So this, when I swap my boundaries from my upper and lower boundaries here, I swap them around, it's now just going to be negative of what I started with. Well, I know that this highlighted portion in yellow here is equal to 12, right? So it's just going to be negative 12. And you could have done this a lot quicker. I think the quickest way to do this would have just been going, they'll swap the terminals. So it's not going to be 12, it's going to be negative 12, because I know that's the result of swapping the terminals. But I'm kind of really spelling it out for you here. But of course, you can work at your own speed. Let's go through the next one now. I know the first thing I can do here is I can take out this 3. So I can take it out to the front. 5 to f of x dx. And once again, hopefully you can see what we've done. By taking that out to the front, I now have this. And that is what we had up here. I know that the definite integral of f of x from 5 to 2 is equal to 12. And I also know that this 3 is multiplying with that. So it's just going to be 3 times 12, which is 36. Perfect. And now we come to the last one here, C. This is the most challenging of all. So let's come down here and let's have a look at it. The first thing I'm going to do is I can see that this is made up of 2 parts. So let's just split them apart to begin with. So I'm going to take this and I'm just going to write them as 2 different definite integrals. So I'm going to go 4 to 2 of f of x dx plus 4 to 2, so my boundaries stay the same, of 4 dx plus, and then I'll just write down what this is, 5 to 4 f of x dx. So all I've done here is I've written that as its own definite integral here, I've written this as its own definite integral there, and this I've just kept the same. Now, initially you should be a little bit freaked out because you're like, what on earth is going on? I started with 5 and 2 as my boundaries, but now I have like 4, 2, 5, 4. What on earth is going on? Well, we know how to deal with this constant, right? That's not really our problem. So let's just kind of move this around a bit. So you can't do this, but you could. Actually, I'll rewrite it. What I'm going to do is I'm going to rewrite it. And I'm going to put this here. So I'm just copying it straight down. So that I just brought down. And I'm just going to bring this over here. Plus, now this isn't 100% necessary, but sometimes having everything in the same spot makes it a bit easier on our brains. And then I'm going to bring that over there, plus the definite integral of 4 to 2, 4 dx. Okay, let's get rid of all that. Go away. Okay, so we have this. What we're going to now focus on is this part right here. Let's just for a moment consider what f of x looks like. Now, we actually don't know what it looks like, so we're just going to put something random there because what it really looks like doesn't really matter. Let's say it looks like this. Whoa. Something like that. And I know that I'm finding the definite integral for this first part from 2 to 4. From 2 to 4. So let's say that 2 is here, and let's say 4 is here. So this definite integral here is giving me this area. And then 5 to 4, well, here's 4, so I'm just going 5 forward. That's going to give me that. Now, what do you notice about this? I could write this as one definite integral. Instead of breaking it up into two parts, I could rewrite this like this. I could say this is from 5 to 2, right? 5 to 2 of f of x dx. Now this should be ringing some alarm bells in your brain, because this right here is what we started with. This is what they told us. So if we come back to the beginning, 5 to f of x, we know this is equal to 12. So they're just trying to freak us out by splitting them up, because at the end of the day, we know that this is going to be 12. All right. The next thing we have to do is sort out this part right here. So this is the definite integral of a constant. And again, we just need to think this through graphically. Hopefully you can jump to this without actually having to draw it out, but sometimes it's helpful to draw it out. And as we're still learning, it's good that we do so. I know that this line here is y equals 4. So I'm just finding the area underneath the line y equals 4, because that's what, to be a constant, just a straight line there, between the intervals 4 to 2. So I can come over here. This is 2. This is 4. I'm just trying to find what this area is. Do you notice how this is a rectangle? Now, what is the height of this rectangle? Well, because I'm at y equals 4, that means this line here goes through 4, right? So it has a height of 4. And what is the width of this thing? Well, it's just 4 minus 2, which is 2. So a nice way to write this out is to find what this area is just this constant here, 4, times the difference in my terminals. That's going to give me my width, 4 minus 2. So just to repeat, this is giving me my height. This is giving me my width. This is going to be 4 times 4 minus 2 is 2. 4 times 2 is 8. So the area under this thing is 8 units squared. And now I just have to plus these two parts together, 12 plus 8. The last time I checked, 12 plus 8 is going to be 20. And that will be my final answer. So that's how you use definite integral properties to answer these questions. So there's my answer to C, that one right there. This was my answer to B, 36. And this was my answer to A. Hopefully you found this video helpful, and I will see you in the next video.